Hello. I will be explaining acid-base extraction today as my own method of studying for tomorrow's quiz. I took these compounds off of the experiment 4 lab manual, and I'm just going to use them as my example today. So there are 3 compounds to isolate: benzoic acid, azobenzene, and M-nitroaniline. Benzoic acid is acidic because it has a carboxylic acid group. Azobenzene is neutral. It doesn't have an acidic or basic group. And M-nitroaniline is basic because it has an amine group. And it's important to remember that charged species will be soluble in the aqueous layer while neutral compounds remain in the organic layer. Right now, all 3 of these compounds are neutral and will be soluble in the organic layer. So a way you can separate them is through protonation of a basic group or deprotonation of the acidic group. So for benzoic acid, you can use a base to deprotonate this carboxylic acid right here, which will turn into this charged species. This charged species will then be soluble in the aqueous layer, while these 2 compounds remain in the organic layer. Since M-nitroaniline is basic, it's not going to react with the base. And azobenzene is neutral, so it's also not going to react with the base. And similarly, you can use an acid to protonate M-nitroaniline to separate it, because it turns into this charged species right here, while azobenzene remains neutral because, again, it does not have a group that will react with an acid or a base. So I drew a flow chart, a very messy one, but here is a SEP funnel with all 3 of the compounds in it dissolved in a organic solvent like ether, maybe. And then when you use a base, the benzoic acid will become deprotonated into this charged species, which will go into the aqueous layer, and then your organic layer has your azobenzene and M-nitroaniline still dissolved in it. You can isolate the organic layer by just draining the aqueous layer into a beaker. So then you're left with azobenzene and M-nitroaniline. So then to separate the M-nitroaniline from the azobenzene, you can use an acid like sulfuric acid here. Yeah. Is that sulfuric? Yeah. Sulfuric. You know, I'm always confused by the adic-itis stuff. That trips me up sometimes. Yeah, I shouldn't have doubted myself, you know? Sulfuric acid used to protonate the M-nitroaniline. So then it becomes this right here and becomes soluble in the aqueous layer, while azobenzene, the neutral compound, remains in the organic layer. Finally, after you drain the aqueous layer, you're left with just the azobenzene in the organic layer. So pour this into a beaker, and then you can use drying agent to get rid of any remaining water. You can use magnesium sulfate or sodium sulfate. Those are very common. And then to remove excess solvent, you can either put it on the rotovap, or I just watched a YouTube video and someone suggested heating it to evaporate it, which I guess is also an option. And then going back to these 2 beakers, if you want to get back to your original compound, all you have to do is protonate again, give it its give it its proton back by using an acid like HCl, and then here you can deprotonate to get back to M-nitroaniline with a base like sodium hydroxide. And then you have successfully isolated all 3 of your compounds. Okay, goodbye.